Hello, everyone. My name is Joris Peels, and this is another episode of 3D Printing News Unpeeled, courtesy of 3dprint.com. And today we're talking about UpNano. So UpNano has, together with Cubicure, developed and put on offer a new material for 2PP or two photon polymerization. Both firms are Austrian, so that might have been the reason why they decided to work together. And Cubicure makes resins and a production process of kind of hot lithography type materials. And these materials we know already from different vendors in the space have really very high performance properties. And now together, these two Austrian players are bringing these high performance materials to two photon lithography or two photon polymerization, 2PP. So this material is called UpThermo, and UpThermo has a heat deflection temperature of 300 C. So that for polymer is quite high. The guys think that it can be used for electronics, for things like micro injection molding, and just generally high performance polymer applications on the nano and microsphere. So this is a great step forward for UpNano because these kind of high temperature polymers are very difficult to get and very difficult to make. In addition, UpNano also has optics material, a black material, a bioprinting material, and is really spreading out its product portfolio that makes it like a really versatile technology for a lot of stuff on both on like the biological sphere and also in mechanics and in mechanical engineering and in optics. And we're seeing a convergence of these things. We're seeing electromechanical, electro-optical systems. We're seeing biological systems that have mechanical elements to them. And in that kind of convergence, UpNano seems like it could be a very, very versatile kind of package to do research and later on product development and innovations on. So a very, very good move by them. The next thing is a cable robotic 3D printing system for buildings and facades and the like. This has been developed by David Hallbrook of Bauhaus University in Weimar, together with a whole team of people. Now, when we're looking at construction printing, the most popular form at the moment is just a robot arm. Sometimes people then put a robot arm on a track to give it more travel, or they put it upside down, usually on a gantry, to make it come down from the top and then print things. Or they just have a gantry-based system that they build for the entire size, let's say, or the build volume of the house, and then they don't need a robot arm necessarily, and then they just have a nozzle that deposits concrete or other materials from that. Now, we've seen other experimental things. We've seen, one I really, really like is the idea of having a kind of vehicle that can position concrete with a robot arm. Next to that, we've seen people do fanciful things like drone construction, which is flying drones to do it. Now, this is a different thing. We've seen cable-driven systems before. People have tried to do this in polymer, and people have tried to do this in a kind of fanciful way. The idea essentially is that you don't really necessarily have well, you need to put the cable-driven system to a structure, but that could be the house itself, for example. It doesn't have to be necessarily the purpose-built structure. And when you address these cables, you put these cables to it, you can then move, by lengthening and shortening these cables, move the print head, if you will. So this is a completely new way of looking at it for construction printing. It's going to be, you can already look at this, right? And you can see the picture, and you can already see that this is going to be finicky. You're going to have to do a lot of feedback and a lot of compensation for a lot of things. They did this using a PLC, a Beckhoff, I think, PLC, and they must have done some really elegant programming to get this thing to work. But, one can see that this is going to be a very finicky, kind of difficult thing to do. Now, on the other hand, we expect the software part of this, the PLC/programming, compensation for all the feedback loops. We expect that to be kind of a solvable equation, as software and as computing advances. But still, just technically speaking, this is going to be quite the technical challenge. But I'm happy somebody's tackling this, and happy somebody's looking beyond just a gantry system. So what they did at this stage is just made a one-layer printed facade system using carbon reinforced concrete. And just industrial robotics and cable-driven kind of manipulator stage, if you will, and a screw system. That's it. Now they say the advantage of this system, this is quite interesting, is that it's a system that can be easily transported and installed. So we don't have to bring a giant gantry. We don't have to use a really expensive robot or bring one. These things can be quite heavy. We have a quite portable system. Now, if you think about it, this also for certain interior elements, right? could be a really lightweight system to add a flooring or add like, imagine you wanted a floor with heating in it or something like that to add details. It could be a really lightweight system to do that. So, I do think I'm really skeptical towards this system because it would seem just like such a technological challenge. But having said that, there are some applications that make this flexibility, this lightweightedness that could really play to these advantages. And I'm just generally happy that somebody's being creative and trying to think outside the box, quite literally in this sense. The next news is that Electroinks is partnering with Fujifilm. So Electroinks is a U.S. Based maker of cutting edge, usually conductive, not exclusively conductive materials. They make inkjetable, aerosol jettable materials, and they're a materials vendor. Quite a small startup, but they've been in the business for a couple of years. We did a 3D pod episode with them, really nice. And they're making cutting edge materials. And what they've done now is they've entered into a contract manufacturing agreement to have Fujifilm Imaging Colorants Inc., subsidiary Fujifilm, make their particle-free conductive printable material in the U.S. in Delaware at one of the largest inkjet manufacturing plants in the world. Now, the ink they have in this case is one that's specifically formulated for semiconductor packaging. So semiconductor started as a wafer. And you can't just put a wafer into a computer. It doesn't work like that. So you have to put all sorts of things around it. And that's literally called the packaging. It literally packages it, connects it, can put all sorts of other electronic items and microprocessors and things in close to that original wafer and make a complete package, if you will, that can power your computer or does is the main brains behind whatever it is you need to have brains. So this packaging industry is quite big, actually. It's a $25 billion a year approximate industry. And this has been boosted, and I do mention this in the press release, it's been boosted by the CHIPS and Science Act, which is the US's attempt to spend over $50 billion US in domestic semiconductor R&D and manufacturing. So the US is trying to put all of its semiconductor supply chain in-house in order to give it more assurance, in order to give it more an ability to use semiconductors for military purposes, in order to not be so reliant on China eventually. U.S. is essentially fearful that China will catch up with it. And this is a way of stimulating a U.S.-only kind of chip supply chain. So, to then be a U.S. company that then, scales up production seems like a really opportune moment to do this. And it seems like a really good thing to do this as well. There could be a lot of research money, a lot of development dollars in the offing for Electoinks and Fujifilm if they do this. So we would expect more opportunities in the shifting supply chain for 3D printing, either in the construction or either in kind of like packaging or other kind of like cutting edge applications. So watch this space. Thank you so much for your time today. My name is Joris Peels, and this is another episode of 3D Printing News Unpeeled, courtesy of 3dprint.com. Have a great day.